higher temperature to an object at lower temperature when the objects are in direct contact. This is called convection. For example, when we keep the spoon in hot water, the spoon is not hot. After keeping the hot water, after some time, we will feel the spoon in hot because all the particles of movement will be get heat through the spoon, through the hot water. So, two objects are in contact. For that, they will get heat. That is the convection of heat. And also, we have learned about temperature. In which device used to measure temperature? Thermometer. What are the three types of scales? Kelvin, degree Fahrenheit and degree Celsius. What is the SI unit of temperature? Kelvin. Okay, today we are going to learn about convection of heat. What is the topic? Convection of heat. This convection can occur in all fluids. What is the meaning of fluids? Liquids and gases are called fluids. The convection will be not occur in solids because the particles of solids in very closely packed. The particles in liquids and gases loosely packed. So, the convection can occur in the fluids. So, when the fluids get heated, the particles of matter will be expand and decrease their densities. The warmer or lighter particles rises up and cooler and heavier particles takes their place. That is called convection. What is the definition of convection? It means transfer of heat due to actual movement of particles as a result of temperature difference. The transfer of heat due to the actual movement of particles as a result of temperature difference. For example, this is a bowl. This is water. When we give fire, in this water, where it will start to move the particles? In middle. Okay. From the down particles, these are the warmer particles. What is this? Warmer particles. Warmer particles or lighter particles rises up. And cooler and heavier particles takes place their place. These are the cooler particles. So, when we give heat in that liquids, warmer particles rise up and cooler and heavier particles take their place. So, the warmer particles will be go up from bottom to top and cooler or heavier particles takes their place. They will be moved from here. This process will be depends upon the till the temperature will be equal in all the liquids. In all the places are equal. If the temperature will be in all equal in all the places, up to then the process will be considered. Have you understand this? Convection. Convection means transfer of heat due to the movement of particles. It means the warmer particles will be moved from bottom to top. The cooler particles move from top to bottom, so that due to the actual movement of particles because of the temperature difference. This is called convection of heat. One example of convection of heat is sea breeze and land breeze. Listen, about sea breeze and land breeze, you have learned before the classes. Have you remembered that? Okay, what is the meaning of sea breeze? During the day, the air, cool air considered in the sea. The warm air or hot air will be in the land. Then during the day, the cool air blows to the land during daytime. During the day. So during the day, cool air blows from the sea to land. That is called sea breeze. Then during night, land will be cool and sea air will be hot. Land air will be cool and sea air will be hot during the night. So during the night, the land air blows to the sea. During the night, land cool air blows to the sea. So it is called land breeze. Have you understand this? During the day, sea breeze. From the sea, cool air blows to the land. That is called sea breeze. During night, land air, it means cool air. Okay, land air blows to the sea. That is the land breeze. Other few examples of convection is convectors, ventilators and industrial furnaces. Convectors. Convectors means it is a heater. Ventilators means cooler. We will use heater and cooler at home. Why we are using the heater at home? We should keep our room warm. Okay. So, if we keep the heater in the bottom of the room, okay, this is the room, we should fix the heater at the bottom of the room. Why we should fix the heater at the bottom of the room? Because the warmer air rise up. The cooler air will be take their place. So, we can keep our room warmer. If we fix the heater at the top of the room, it's not the circulation will be processed. The air will be not circulate properly. So we should fix the heater at the bottom of the room. Then ventilators. We should fix the ventilator or cooler in the top of the room. Because the cooler air will be take place. The warm air rises up, cooler air and lighter air will be takes their place. And industrial furnaces. When we cook in our home, smokes and gases will be given out. Do you know chimney? In our house, many houses they made chimneys in the kitchen. Okay? In that chimneys, gases and smokes will be go out because the warm air rises up and cool air takes their place. These are the examples of convection. Next process is radiation. Radiation of heat. Already we have learned conduction of heat, convection of heat. Next one is radiation of heat. This is the another one process. This process at which heat energy from a source is transferred without the help of a medium. So, heat energy from a source. Heat energy from a source is transferred without the help of a medium. It has only one source. Without any medium, they will be transferred the heat light. Heat energy. Heat energy from the source. For example, sun. Sun transforms energy to the earth without any medium. Sun directly sends the radiation to the earth. It is an example of radiation. This radiation occurs in all the directions. The energy of radiation is called radiant energy. The energy of radiation is called radiant energy. We will get heat from the sun. That energy is called radiant energy. Without any medium, we will get heat energy from the sun. The sun transforms heat energy to the earth without any medium. So it is called radiation. The energy is called radiant energy. Radiation will be occurring in all the directions. Next one is absorption and emission of radiant energy. Absorption and emission. For example, this is an object. If the object has higher temperature, that surrounding of the object has lower temperature. So, from this object, heat energy sent to the surroundings. Heat energy transformed to the surroundings. This is the radiation. So, this surroundings will be absorb the heat energy because here less temperature, lower temperature, in the object has higher temperature. So the surroundings absorbs the energy from heat energy from that object. If surrounding has higher temperature, the object will be absorb the heat energy. Do you understand? If the surrounding has higher temperature, the object has lower temperature. So, from the surrounding, transform the energy to the object. So, this is emitting. Surroundings emitting the heat energy, object absorbing the energy. In the first process, object emitting the energy and the surroundings absorbing the heat energy. If the temperature is same on both, they will not transfer the radiation, they will be not emitting or absorbing the heat or radiant energy. If the objects are same temperature, they will be not emitting the heat energy or they will be not absorbing the heat energy. If an object is rough or hard, the radiant energy will be absorbed more. So that is called good observer. If the surface is very shining or very clean, they will be reflect the light. That is they will be not absorb light or heat. That is the good emitter. If the substance absorbing heat energy, that is called good observer. If they are not absorbing the heat energy, they are called good emitter. Next one is good reflector. Already we have learned about reflection. Yes. If the heat transform here, they will be reflect. If the heat is reflecting, the surface is very shiny. It means clean water or glass. So they will be not observed. This is the glass. So glass will not absorb the heat. Reflected the heat. So it is called emitter. Good emitter because they will be not absorb the light, they will be reflector. So it is a good reflector and good emitter. If the surface is very hard, the light will be absorbs. Light absorbs here. So it is called good observer and poor emitter. Good observer and poor emitter. We have some examples of absorption and reflection of radiation. Listen, light colored buildings stay cooler in summer because they reflect much of the incoming radiant energy. Electric room heaters are provided with a highly polished reflector so that maximum heat is reflected into the room. We wear light colored clothes in summer because they reflect most of the sun's radiation and absorb very little heat. So they keep us cool. We wear dark colored clothes in winter season because they absorb radiation and keep us warm. And another one is hot water pipes, cooling fans at the back of the refrigerator are painted black so that they can absorb and emit heat quickly because the refrigerator will be cooler. These are some applications of absorption and reflection of radiation. This is the comparison of conduction, convection and radiation. First one is, in conduction, transfer of heat from particle to particle through the matter, from particle to particle, transferring of heat through the particles of matter from particle to particle. In the convection, the transfer of heat by actual movement of particles in matter. Because of movement of particles, warmer particles rise up, cooler particles comes down. So, actual movement of particles in matter. Then transfer of heat without medium, passing through an object without medium. Then second one, conduction takes place mostly in solids because the particles, arrangement of particles will be very closely packed. So the conduction takes place mostly in solids. Convection takes place in fluids, liquids and gases. In radiation, they don't have any medium. So automatically they will be in vacuum. It means in air. The conduction is the slow process. Convection is the faster than conduction. And radiation is the fastest of three. When we compare conduction, convection and radiation, radiation is the fastest process. Next, conduction, any direction based on conduct. If we keep any object in conduct, it will be any direction. Then in convection, only in the upward direction. The warmer particles rise up. So it is upward direction. In radiation, in all directions. Radiation of energy will be all directions. The radiant energy from the sun. The heat of energy passing through all the directions. These are the comparisons of conduction, convection and radiation. Normally, heat transfers from one object to another object. Then how to control the transferring of heat from one object to another object? By using thermostats, we can reduce the convection, conduction and radiation. This is the example of thermostats. We use thermostats in our home to keep the hot water reduced heat by convection. It transferring from higher temperature to lower temperature. So this glass walls control the heat energy passing from object to another object. Next one is, in between the inner wall and outer wall, it has vacuum or empty place. And we will say that in air. What is the use of this vacuum? Reduces heat loss by convection and convection. This glass walls used to reduce convection. This vacuum reduced heat loss by convection and convection. And the next part is cork stopper. In the another one is the inner surface of the outer wall and outer surface of the inner wall is made by silver coated. Okay, what is the use of this silver coating? Reduces heat loss by radiation. Vacuum reduces heat by convection and convection. The silver coating reduces heat by radiation. And in the mouth of the thermos flask, it closed by cork. So this cork prevents heat loss by convection. The cork prevents heat by convection. And the next one is plastic case. Almost outside the thermos flask made by plastic case. In this thermos flask vessel, it will be keep on the cork pad. What is the use of this? This thermos flask keep the hot water in hot and cold water in cold for long period of time. So that they use this thermos flask, keep the hot things and cold things. This is the liquid of a flask. Have you understand this? This is the example of controlling convection, convection and radiation. And also you should refer the book. You should refer this lesson fully. We have completed the lesson heat. So you have to prepare the